Hello everybody and welcome back to our next lesson on the Pythagorean theorem. Today we are looking at finding distance on the coordinate plane using the Pythagorean theorem. Let's take a look at a few examples today. This first one we're going to look at here says Carrie walked from her home to the ballpark. So she's starting here and she's ending up here. On her way she stopped at the post office. The distance she walked is displayed on the coordinate plane. How far did Carrie walk altogether? Okay, so here's the thing. This distance right here, we can figure this out easily. We don't have to use the Pythagorean theorem to figure out that distance right there. We can just count the units, right? And the number of units there is 1, 2, 3, 4, 5, 6, 7. So we know this is 7 units right here. No Pythagorean theorem needed. However, from the post office to the ballpark, that is a diagonal slanted segment. We cannot count that on the coordinate grid. It's not going horizontal or vertical like the previous segment that's highlighted in green. So we have to make a right triangle here, or we can make a right triangle here to find the distance between the post office and the ballpark. Why would we do that? You may be wondering. Well, let's draw this right triangle and then it may make some more sense. So if I draw that right triangle right there, I can identify both this leg, the distance of this leg, and the distance of this leg. And because of that, I can find those two distances and use the Pythagorean theorem to find the hypotenuse. Remember, the Pythagorean theorem helps us find missing side lengths in right triangles. So that's exactly the situation we're trying to produce here. So let's count these legs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one's 12 right here. And this one is 2, 3, 4, 5, 6, 7, 8, 9. All right, so now I can use the Pythagorean theorem to help me figure out the distance of the hypotenuse. I have the two legs. So 9 squared plus 12 squared will equal c squared. Let's plug it in the calculator. I can plug that all in at once. 9 squared plus 12 squared, so that's 81 plus 144 equals c squared. 81 plus 144 is 225 equals c squared. And to cancel out the square, we square root both sides, and then we'll get 15 equals c. 15 is the square root of 225. So that means that the distance of C is 15. So it asks C what's the total distance she walks, the total distance Carrie walks. Well, first she walks 7 units or blocks to get to the post office, and then she walks 15 more from the post office to the ballpark. So altogether, she walks 22 units or blocks to get to her destination. So in summary, let's think about and conceptualize what we just did to figure that problem out. How can we use the Pythagorean theorem to find the distance between 2 points on a coordinate plane? First, we created a right triangle, and then we used the Pythagorean theorem. That's the process that we use to figure out distance on the coordinate plane. Let's take a look at another example. Here, we're just given a coordinate grid and we're given 2 points. So let's plot those 2 points first. A is at -2, -3. So there's A. B is at 4, 5. So B is all the way up here. I need to make a right triangle to figure out this distance right here. Well, how would I do that? I can make one of 2 different triangles and they would both help me find the answer. Here's the first one I could make. That's one option. But some of you may be looking at that and saying, well, I think we should just make the triangle like this. Guess what? They're the same triangle. Both of those triangles will produce the same answer for segment AB. What's the length of this horizontal segment? The length of the horizontal segment is 6 here, and the vertical segment is 8. This is 8, this is 6. So again, no matter which triangle you're using, you're going to find the same answer for segment AB. Again, whichever triangle you're using, your calculation will be 6 squared plus 8 squared equals, we'll call it AB squared. So 36 plus 64 equals AB squared. So that's 100 equals AB squared. Square root both sides to get AB. So the square root of 100 gives us 10. So AB is 10. Let's do one more example, and this one is very similar to the question that you guys are going to need to do here for your practice with this topic. So here, number 3, it says the post office is 4 kilometers north of your friend's house. So let's plot that. Post office 4 kilometers north. So 1, 2, 3, 4. We'll say PO for post office. The library is 7 kilometers east of your friend's house. So F for friend. So there's the friend's house. To the nearest 10th, how far is the post office from the library? So this is, I read this wrong, this is library right here. We'll call it L. So the library is right here. Here's the post office, here's your friend's house, and you're trying to find the distance from the post office to the library. You're trying to find that distance right there. So let's call that C. That distance can be called C. This vertical distance is 4. The horizontal distance is 7. So let's use the Pythagorean theorem here. So we'd say 4 squared plus 7 squared equals C squared. You may be noticing that when you do these types of problems, you're always going to have the legs and you're always going to be solving for the hypotenuse. The legs will always be horizontal or vertical segments which you can count and identify, and you use them to find the hypotenuse. So here again, we're doing that process. So we have 16 plus 49 equals C squared. So that means 65 equals C squared. Square root both sides. C is the square root of 65, which is just going to be just a tad over 8. Because remember, the square root of 64 is exactly 8, right? So the square root of 65 is just a little bit bigger than 8. We'll just leave it the square root of 65. It's okay to leave square roots like that if they don't reduce nicely. It's okay to leave them square root of 65. But if it asked you to round to the nearest decimal point, or to 1 decimal point, you could say 8.1. So to the nearest 10th, it's 8.1. And it's in kilometers. So 8.1 kilometers would be another way to express your answer for that one. If you take a look here at number 4, and maybe a good one to try out here. In fact, this is the problem that I'm giving you to try for your practice today for points. I reworded the question a little bit. It's just a tad different than this one, but this would be a good one to try. It's very similar to number 3. So make sure you understand those, and then start your practice. You'll have to open a file on the practice questions. There's a file to open up. It's a Google Drawing document that you will annotate and use to kind of figure out your answers and draw your triangles. You're not going to turn in that Google Drawing. You're just going to use it to figure out your answers and then submit your answers on the little quiz that you'll open up here on Schoology. As always, if you have questions, please, please, please reach out. Schedule a conference. We miss you guys. We want to talk to you guys. We want to help. So make sure you take advantage of the opportunities that we're providing. Hope you guys are doing well. Be well and keep it 100.